Okay, how's everybody's day been so far? Been okay? All right, good, good, good. A couple more days of testing, a couple more weeks of school, and then we'll be completely done. We don't have a whole lot today. A focused activity, a couple problems off the notes, and then we'll go ahead and call it for today. So let's see here. Number one, a radio telescope has a parabolic dish with a diameter, that's the new math word for diameter, of 100 meters. The collected radio signals are reflected to one collection point called the focal point, being the focus of the parabola. If the focal length is 45 meters, find the depth of the dish, rounded to 1 decimal place. Okay, so I would probably start this with a cross section, a little picture here, and this is definitely not going to be to scale. But we know that it has a diameter of 100 meters. Okay, it also tells me the focal point, how far is it from the vertex? 45 meters, okay. So let's say our focal point is right here. Now, why don't we go ahead and make the vertex at the origin? That'll make things a lot easier here. So 0, 0. So there's my HK, so we know this has a distance of 45 meters. Now, what we're trying to do is find the depth of the dish. So basically, what is the height of this dish right here, the way I drew it? Okay, so how have we looked at a problem like this before? How could I approach it? Okay, well, let's start with what we know. What's the general form, or standard form, I should say, for a parabola that opens up like this? What would be squared, x or y? X would be squared, and 4p would be positive, okay. So we have 4p times y minus k is equal to x minus h squared. Perfect. Now, what are we really trying to find here in terms of the equation? What variable do you think? I'm trying to find the height, that in what they're calling the depth. What variable represents that? Miriam, what do you think? Okay. Well, let's just go ahead and start to eliminate what we know. Do we know the distance from the vertex to the focal point? Yes. Okay, so we have P. We have the vertex at 0, 0. So that gives me an HK. So we have those. So we're either looking for the X or the Y. We're looking for the Y. So what's the value of X we could use? You could use 50. Remember, every parabola is going to be symmetrical. So if this is 100 meters across, then going from the origin to, say, this point right here, we could say 50, and then we just don't know what the Y value is. That's what we're trying to find. Okay. So now I have 4 of the 5 variables. I can go ahead and plug in, basically just solve this equation. Okay. So I'm going to plug in P equals 45. What's 4 times 45? 180. So 180 times, now I need y minus k. So y minus 0, well, that's just y, equals. Then I need x minus 0. So it looks like 50, again, minus 0, but that's just going to be 50 squared. Okay. So what's 50 squared? 2,500, bless you. So 180y is equal to 2,500. And then all I got to do is what? Divide by the 180. So to 1 decimal place, about how many meters deep is the dish? $2,500 divided by 180. About 13.9. There we go. There we go. Like I said, it was not going to be to scale. Absolutely not. Okay, questions. All right, easy. And how many focused activities do you have right now? You got 2, numbers 3 and 4. You'll get number 5, if not Friday, then early next week, but I'm planning on turning them in next week because we are quickly running out of time. So hang on to these. Should be a good grade to help finish up. Okay, so there's not a whole lot I want to do today. I just want to go ahead and look at a couple of problems here with parametric equations, and then we'll be done. What time we get out of here? 16. Okay, we got plenty of time. So what have we done with parametric equations so far? Or even let me take a step back. What are parametric equations? What do they do for us? Okay, something to do with an object moving. Now, we can get the direction graphically, but let's say the parametric equations, what can those provide? Or what's the parameter? What's that new variable? T. Okay, so we're talking about time. All right, so what we're talking about here is taking some rectangular equation, just a normal equation with x and y, and we're introducing this third variable that we call a parameter, and we use the variable t, okay, for time. Well, you're always going to have a pair of parametric equations. The horizontal parametric equation will tell you at any given time how far horizontally an object has moved. Okay, the vertical parametric equation will at any time give you the vertical height of a moving object. Okay, so really it kind of provides you more information than just the standard, XY equation. Well, on Friday, we started by graphing these, and we talked about the orientation. That was the direction that an object was moving. We created a table. The order in which we plotted the points was the direction in which we placed our arrows. And then yesterday, we took a pair of parametric equations, and we rewrote them to get the rectangular equation back. Well, what I want to go ahead and do today is start with a rectangular equation and write a pair of parametric equations. So it says, as you saw in the first example, parametric representations are not unique. By varying the definition for the parameter, you can obtain parametric equations that produce graphs that vary only in speed and or orientation. Now, I'm not interested in the speed here. I am interested in the orientation, though. But it's really important to realize that a single equation, your rectangular equation, can have many, many different pairs of parametric equations to describe it. It just depends on how you want to define your parameter t. Now, the easiest way to do this is just to say t equals x. You can always get a pair of parametric equations simply by saying t equals x, and it works for anything. Let me give you just an example here. If I were to say, okay, y equals 3x squared minus 5x plus 2. I just gave you a quadratic in standard form. Okay? And I wanted to immediately come up with a pair of parametric equations that would describe this. Well, I could immediately start by saying x equals t. That would represent my horizontal parametric equation. Now, in order to find the vertical, all I have to do is take the rectangular and replace every x with t. So then it would be y equals 3t squared minus 5t plus 2. So there you go. That pair of parametric equations would represent that rectangular form. Okay. Now, it can get a little more complicated depending on how you want to define t, but what I want you to realize for these three examples, A, B, and C, you're given different definitions for t, but we're going to apply them to the same function, x squared plus 4. Okay, so this first one's going to be pretty easy. All right, I want to define t just by saying t equals x, right? So I already have my horizontal parametric equation. I know x equals t. Just like I did a few moments ago, or a few seconds ago, I have y equals x squared plus 4. If I want to find the vertical parametric equation, I'm simply going to replace x with what? There you go. So it would be y equals t squared plus 4. There you go. So that right there would represent x squared plus 4, the rectangular equation. Okay. You can always define t as simply x. Now, let's go ahead and review a little bit. Let's say I want to go ahead and show you that that will give me the same graph. Y equals x squared plus 4, that's the parabola parent, but what's been done to it? All he's been is just shifted up 4, right? So let's see what we get. Let's go ahead and graph, bless you, this pair of parametric equations. So I've got t, x, y, just like we did on Friday. And we're not given an interval, so we'll just choose some random values. -2, -1, 0, 1, 2. Okay, some random integers. Now, it's going to be really easy to fill in the second column because we know t equals what? X. So whatever I plug in for t is what I get for x. So this is -2, -1, 0, 1, 2. Okay, but now I'm going to take those chosen values of t and I'm going to plug them into my vertical parametric equation. So y equals t squared plus 4. First one would be y equals -2 squared plus 4. And what's that going to give me? 8. All right. And then let's just go right down the line. -1 squared plus 4. Okay, or 5. 0 squared plus 4. And then you notice whether positive or negative, because I'm using consecutive values of t, I'm going to see the symmetry in the graph. So this would also be 5, and this would be 8 right here. Okay. Now you could add the fourth column, which would be what? The ordered pairs. If you want to, I'm not going to worry about it here. Like the first ordered pair, -2, 8, second ordered pair, -1, 5, and so forth. So let's plot these. So there's -2, 8, -1, 5, 0, 4, 1, 5, and then 2, 8. Okay. Now, we were not provided an interval for t. We just kind of chose some values of t to go ahead and plug them in. So there's no restriction here. I'm just going to go ahead and draw my graph. The only thing left, what direction am I going to place my arrows? Or how do I know how to do that? With the values. What do you mean, Ford? So look at the time. Okay, you're right. Okay, you always want to create your table, and we would normally do this anyway, from smallest to largest on your t values. So the ordered pairs that are created, that's the order in which you'd plot them. So this was the first, second, third, fourth, fifth. Okay. So the direction you plot them, I went from 1 to 2, so I'm going to draw an arrow, just like that. And I'm going to keep that arrow going around the parabola. In fact, if you were to just look at it, isn't that x squared plus 4? Okay, there you go. All right. Now that's the easiest way to create a pair of parametric equations. Just define t equals x and go from there. But what if I wanted to define it differently, like b? Here we're going to define it, t is equal to 4x plus 1. So I want to define t as a linear function. But I want to use the exact same function. Y equals x squared plus 4. Okay. Well, the first thing I got to do is take my definition here. I want to solve it for x. Okay. The result is going to be the horizontal parametric equation. So how am I going to solve this for x? Okay, subtract 1. So t minus 1 equals 4x. Then what? Divide by 4. So 1/4 t minus 1/4 is equal to x. So right there, that's half my answer. That is the horizontal parametric equation. Okay. So I know x equals 1/4 t minus 1/4. Now, I just want to figure out what the vertical parametric equation is. How do I do that? Plug what in where? There you go. See, we solved this definition for x, so I know x equals this. So I'm going to go back to the rectangular equation. Everywhere I have an x, I'm going to plug it in. So y equals, that would be x squared, so that's 1/4 t minus 1/4 squared, and then we have the plus 4. Okay. Now that would be your vertical parametric equation. Of course, you know, any simplifying, combining, things like that. I mean, technically, you probably could go ahead and leave it like that. It would be just fine. But I could have sworn I just heard somebody say, let's go ahead and expand it because it has fractions. Okay. So let's go ahead and do that. I think it came from over there someplace. Somebody said. Trust me. Okay. All right, so I want to go ahead and expand 1/4 t minus 1/4. So we could go ahead, write it out, then use FOIL, but why don't we go ahead and just use that little rhyme? What was that? Square the left, square the right, double the middle. Okay, so let's see here. Jack, I need to square 1/4 t.
Wait, do you want me to tell you what you get?
Yes.
1/16 t squared.
Okay, so 1/16 t squared. And then who else can I talk to? Rhett. I need square the right. 1/16. Okay, and here's the tough one. Skylar, I need double the middle. I need double the middle. There is no pass. Phone a friend. So let me walk you through the process. We squared the left, we squared the right. Double the middle means I want to multiply the two together. So what's 1/4 t times negative 1/4?
Were you thinking of doubling the negative, the minus? No.
So that would be a negative 1/16 t. But then I want to double that. Okay, so there you go. Skylar, all you got to do is just tell me what it is now. So I wrote it out for you. All you got to do is tell me what it is. So it's minus what? Are you okay? Okay, a little more. There you go.
Just say numbers so you get it right.
Minus 1/8 t. Okay, and there's something we're missing. Plus 4. There we go. Okay, that is a 4. Let me do that again. Okay. Now there's only a couple of like terms here. I'm needing 1/16 plus 4. So that would be the same as adding 64/16 because that is 4. So my vertical parametric equation, 1/16 t squared minus 1/8 t plus what? 60, 65/16. Now this is a different set of parametric equations that would also represent that same equation. Okay. Now, if I were to go ahead and graph it, if I went ahead and took the time to create another table, just like we did a moment ago, I'm still going to get that exact same graph. The only thing that's probably going to be different for us, if it's going to happen, is the orientation. The orientation could change direction. Now, it's very possible the speed could change direction as well, but I'm not worried about speed with this. Okay. How do we feel writing parametric equations for a rectangular? Does anybody have any questions? Okay. That is all I wanted to go ahead and do today, so thank you very much.